Welcome to Turning Pages, a series of in-depth conversations with authors about their works. All right, a professor of civil engineering at the University of Colorado, Denver, Wes Marshall's book is called Killed by a Traffic Engineer, Shattering the Delusion that Science Underlies Our Transportation System, out now through Island Press, and he joins us on the program. Welcome, Wes.
Thank you for having me, Michael.
My pleasure. It's a fascinating book, and there's lots to talk about. I kind of want to talk about the origins of it, though. In the acknowledgments, you talk about talking to your research students, your graduate students about, find what drives you crazy. And I'm curious, what specifically was driving you crazy? Because there's a lot of things to drive one crazy in this book.
Yeah, no, I kind of joke I made a career out of my pet peeves, like the things that drove me crazy, drove me to become, sort of what I am in terms of academia. So, yeah, there's a lot of things I could point to, like when I was working as a consultant, and I grew up right near the Boston area, and what was always interesting to me is that a lot of the stuff we were building was never as good as the stuff I saw in and around me, and that was sort of the first thing. I think the bigger thing that really drove me straight back to grad school is when I finally moved to a place in Connecticut, and it was the first time I lived in a place where I literally could not leave my street without being in a car because it was just so dangerous that next street, and I could see like a corner store, not that far up, and I would have to drive there. And when I asked my neighbors, like, how do you all live like this? Nobody knew what I was talking about. And I mean, that drove me crazy as well.
So experiencing that neighborhood kind of maybe planted the seed for what became this book in some sense?
In a sense, I mean, I started asking myself why, like, why weren't these things we were building at what was a pretty progressive firm. Like, why weren't these things as good as the stuff I saw in Boston? Like, why did we have to build roads this wide, or why did we need this much parking? And then when I was in Connecticut, it's more like, well, why is the street network built in a way where you have to go onto this major road, and why are there no sidewalks? And once I started digging down some of those holes in the workplace, trying to understand why, like I started seeing that there wasn't much to uncover. There really weren't a lot of good scientific reasons as to why a lot of the things we were doing.
So that leads me to the question that you kind of raise in the book in terms of like how much specialized knowledge someone needs to go through in school to become, a traffic engineer, right? Like, because you talk about like doing like one course basically, and to me, like the comp feels like if a med student did like one surgical rotation and was like, okay, I'm a brain surgeon now.
Yeah, and I don't think I really understood that at the time. So when I was an undergrad student, I went to University of Virginia, and within the civil engineering program, we had to choose a concentration, like structural or environmental or transportation. At the time, I chose structural, thinking, someday I'd become an architect or something like that. And within that, I took one transportation engineering course. But then later, when I got into the workplace, like I ended up getting my professional engineering license in transportation because that's a lot of the work I was doing, and that's where my interest ended up lying. But I had assumed that a lot of the people that ended up in transportation had taken more courses. And when I started to dig into it, that wasn't the case. I mean, most of the people I were talking to were taking one or two. Some had taken zero, and that was really fascinating. Like the way our college accreditation systems work, you do not actually have to have any transportation courses within a civil engineering program to become accredited. Therefore, like, we have a professor here at my university. She worked for 20 years as a professional engineer, as a transportation engineer, and she had never taken a single course in this until she took, after working for all these years, she came back and got her master's degree, and continued on. But before that, she'd worked forever without any courses. And I was like, oh my God, like this is what we're doing?
So it's twice now you've mentioned, digging into it. So like, is that in your graduate work you start digging into it, or is it like postdoc, or like how, like what does the process start in terms of this like rabbit hole of research that you talk about in the book?
Well, when I went back to grad school, the first project I had, I got thrown into a parking project. And at the time, I was like, oh, this is kind of boring. Parking's not that exciting. But once I started reading some of the literature on it, Donald Shoup, he's sort of the guru of parking. Like his book that became famous later, The High Cost of Free Parking, it wasn't out at the time. So I was just reading some of his older research that he had done, and you start seeing like we have a book called Parking Generation that's supposed to tell you, given a certain land use, how much parking you need. And when you see some of the research he did on as to where those numbers come from, as to how little there is behind them, you're like, oh geez, like we're really using this to figure out how much parking we need. And I think I took that mentality to me as I continued on with my other research. So I ended up doing my own dissertation on street networks. And if you live on a cul-de-sac or if you live on a gridded network where you're safer and that sort of thing, and trying to understand why we had a big shift from more gridded neighborhoods to more cul-de-sac tree-like ones, like that shift, like it, they said it was for safety, they said it was scientific, but it really wasn't. And I think that mentality sort of seeped into wondering why everything we're doing in traffic engineering, whether it's level of service or how we figure out what a speed limit is on a street, trying to figure, well, why do we do it this way? And I kept going down these various rabbit holes. And, almost every time you realize there isn't much at the bottom of those rabbit holes.
Yeah, it seems like the answer you get sometimes when you reach the bottom is like, well, because, right? Like that in the same way that when I talk to my kids, I'm like, because isn't an answer, but like it seems to be the one that's given or the rationale.
Well, that's what is given now. I mean, when you ask people now, like why we do X, Y, or Z, that's what I was being told. That's just the way we've always done it. So there's inertia to it. And if you find like, some of the original studies, like they knew full well that this wasn't the end all be all study. And they would say, oh, we need to have, more research on this. We need to look at safety a little bit better. And, we would cite that study at the beginning and then, 10, 20 years later, we wouldn't even cite it anymore. But just the idea of something perpetuated. Like one example I give, in traffic engineering, we've long had this mentality that wider roads are safer. And I was always wondering like where that came from. And when I found the original study, it was like in the 1930s and they compared 18 feet, like curb to curb road, 18 to 20 to 22 to 24 feet. So the widest road they looked at was 24 feet. And yes, that was safer than the 18-foot road. So in that study, yes, wider road was safer. But we extrapolated that to, 60, 80, 100, 120-foot roads. It doesn't hold, but we never kept citing that study. So just the idea perpetuated, not the actual research. And when you ask people, well, why do we think this? Oh, it's just because, like, here's our theories, but we never proved them, like we should have.
How much like pushback did you get when it like when you would ask a question like this, or was it because you were doing research on like papers and exist like you're not necessarily talking to engineers about this?
Well, when I was a consultant and I would ask, people I work with, because I was a young engineer, so you'd have bosses of various engineers above you. So I would ask them, and most of them, didn't know, didn't really, want to get into it, didn't know the time of day. Like we were, as a consulting firm, your job is to make money to get these things done as quickly, as efficiently as possible. They didn't feel like they always had the time or resources to look at it in the way that I was curious about it. I mean, there was one or two people that, dealt with my nonsense and tried to answer it. And we would talk through these things. But, once I got back to academia and I was getting my master's, my PhD, like I found an advisor that was perfect for me in that he was curious about the same sorts of stuff. And, he gave me enough rope for me to go down these holes to find out this stuff. So it worked out well. A lot of it I ended up doing later. I mean, some of those, and some parts of the book I did do like during my graduate work, but a lot of it was just the last few years, like during COVID, when I could lock myself in my office and dig through hundreds of old journal papers from the 40s, 50s, and 60s.
So does this then represent like an agglomeration of like a few different phases of work for you then? Like have you pulled from different periods in which you were kind of doing research then?
Well, yeah, I mean, I really started the book in earnest in 2020. So when COVID hit and, I did a couple things at first, but then I knew this book was had been in the back of my mind for at least a decade and I didn't really plan out exactly what it would look like. And that's when I started doing that. And I was trying to figure out what it's going to look like. How can I actually get an idea of what we were doing and why? And I mean, that's when I started, like I said, digging down those rabbit holes to actually find the original journal papers or books or whatever it might be. because I wanted to hear it from the voice of those traffic engineers at the time. Like it's easy for me to say, well, this is dumb. Like, why do we do it this way? But if I hear their perspective as to why they were thinking, and most of the time, they weren't being evil, they weren't, you know, overstepping. They were saying what they knew at the time, and we just over the years interpreted things differently than they intended. But there were times when like a CEO of a car company decided we should measure safety this way because it makes cars look safer, and we've been doing it that way ever since. So there was a little bit of that, but you're right. It was it's a 400-page book where I read like literally 1,000 old books and papers. So it took a long time, and it was a culmination of a lot of different years and research phases of my life.
You mentioned the car CEO there and about measuring safety. So measuring and maybe mismeasuring or misrepresentation of measurement is like a recurrent theme in the book. Um, like you create the like fictional places of Driveton and Hearsville and kind of point out that like Driveton's safety rating would be higher than Hearville and just the way that the numbers get jobbed. How often did you come across like because you were talking about things that irk you to begin with. How often did you come across situations where like the way that the measurements are done is designed in such a way that it like supports cars?
Well, I mean, that was the big one. I mean, that was literally the how we do crash rates, like how we fundamentally measure safety. And, this guy, that he was the president and CEO of Studebaker. He wrote a book in like 1930s called Seven Roads to Safety. His name was Paul Hoffman. And at the time, he was concerned that cars are being made to look unsafe. And he made the right point that we need what's called an exposure metric. Like we can't just, compare the number of crashes or severe injuries. Like we need to have an understanding of, maybe how many people there, how much people drive, that sort of stuff. So he made the right point. Yeah, we needed to normalize it in some way, but then he just picked the one that he liked best. And then he barnstormed the country telling everyone to use this. And it was a burgeoning new traffic engineering discipline. So we listened. We took this. We ended up codifying it into sort of the federal regulations. But, to thinking about Driveton and Hearsville, like the way it works is the numerator is fatalities or something. The denominator is vehicle miles traveled or vehicle kilometers traveled. And with that, there's two ways to get better safety. One is reduce crashes or reduce the number of fatalities. The other way to get better safety is just to increase how much driving we do. And we look at the history of our country, probably the similar in Canada. We've done a good job of increasing driving. We've not done as good a job as decreasing the number of fatalities or injuries in the road network. So it looks like we've really improved safety. And I kind of joke, like mission accomplished. Like we did it when I show the big graph over the years. But when you really dig into it, we haven't. And not only that, it's led us to think that places that would lead to more driving are safer than they really are. And it always this one started when I was doing my dissertation and looking at the gridded networks versus the tree-like ones. And it just didn't make sense to me as to why we weren't treating, road fatalities like any other health impact where we do it per population. Like, yes, maybe per mile makes sense if we're looking at a particular road, but we're the people living there. So it's a personal human thing. Like, why not treat it like we treat every other health impact and we normalize per population. And when you do that, you get a much different answer with so much that we do in transportation.
Right, like it's a scarily larger number.
Yeah, it's scary. We haven't had the improvements that we think we've had. And, you start seeing the things that maybe we thought were safe aren't, and vice versa.
Yeah, you write about, in other disciplines, safety critical systems are engineered where a malfunction may result in a death or injury, and then the threshold for reliability is what, 1 times 10 to the ninth power per hour. Um, one in every 1 billion hours is too many, and when you calculate that in terms of U.S. Traffic time, it's 300 times worse than the safety critical threshold for reliability.
Yeah, and we never think of it in those terms. We think of, I mean, the way we do all safety related measurements is all relative. So we compare it to the normal. So the normal of this type of intersection sees this many crashes, this many severe injuries, this many fatalities. And does the intersection we're looking at, is it above the norm? Is it below the norm? And that's how we determine if it's safe or unsafe. And we never ask, well, is the norm safe or not? And if you think about things from the bigger picture more comprehensively, it's easy to acknowledge that what's normal isn't safe.
Right. And so that kind of leads me to the design aspect of this, and that like the purpose of the design isn't ultimately about safety, right? Like what in terms of like rank priorities, uh, traffic engineering's design is to move traffic.
Well, I mean, when you ask a traffic engineer, or you ask sort of anyone in any field, they say, well, safety's our first priority. And they always say that, but it's just blatantly not true. And it's clearly not true in transportation because when you look at our design protocols, it's set up to start with capacity, and not even capacity today, capacity like 20 years from now. And usually this means capacity for cars. Like we need to figure out how many cars there were going to be 20 years from now, and then make sure our road is built to be big enough to handle that number of future cars. And we just assume that safety is embedded within a lot of these things we do, but the reality was it wasn't. A lot of times they told us, hey, you need to add safety to this, and we never did. So, capacity usually comes first, then speed comes next, and then oftentimes cost is the third concern. Safety, at best is third or fourth.
And so then that leads to the three E's that you talk about, and the enforcement and education kind of superseding engineering in terms of like those being where we try to prop up safety.
Well, that's interesting because I feel like the problem with that is often just the way we interpret our crash data. So whenever a crash happens, the police will go out there and they'll figure out which road user was at fault or most at fault. And the way that gets into our database, so we get this crash database, we have all these different crashes, and you can sort of figure out that it's usually like 94% of our crashes are caused by human error. So somebody made a mistake, but whenever you think that, your first reaction is, well, how do we fix human error? Well, it's easy. Well, we need to either educate these people to do better, or we need to enforce the rules better. So oftentimes for an engineer, there's no incentive to help the situation with engineering because all our data is telling us we have a human error problem and that should be fixed with enforcement, education, or maybe even wait for some technology to be the panacea and come save the day. But when you zoom out just a little bit and you think about some of these crashes, a lot of times we build like a wide road and you could easily go, very, very fast on it, but we put a speed limit sign to ask you to go slower. If you don't go slower, we say that's a mistake. We have a human error. We need to have better enforcement. We need to tell you not to speed. But you can also imagine, well, there's an engineering solution to this too. We could design the road to make it hard to go that fast. Or even a situation like jaywalking. Somebody jaywalks, gets hit, and gets killed. We blame them for doing so. But when you look at the situation we put that road user in, oftentimes the nearest crosswalk is, like a half mile away. And even if they walk that far, it's kind of a crappy crosswalk. And if you look at, pedestrian infrastructure between where they were and that crosswalk, there's probably missing sidewalks or whatever it might be. So to me, that's an engineering failure. And but our data is telling us it's not. Our data is telling us it's a human error problem. And that's so problematic that, it takes us out of having a feedback loop and it gives us no incentive to do better.
Yeah, I was thinking of that in relation to like big box store parking lots, and the fact that like if you wanted to go from one store to another, very often you have to get back in your car and drive to another one rather than like cross a place where it's not designed for it. And it's like it's just like there's no way to do it other than with the car, and we kind of create those situations on our streets too.
Yeah, I think we need to realize that a lot of the folks in our transportation system are, just responding to the transportation system we put in front of them. Like they're crossing, they don't want to die, but they're crossing where it makes sense for them. And I try to, suggest, I have a safety class I'm teaching this semester to graduate students. I'm trying to help them ask the why question. Like, why do you think this person did what they did? Like, what is the role that engineering played in why they did what they did? Let's not just blame them for what they did. Try to figure out why. Like, and people say, well, we still have like DUIs. People shouldn't be drinking. They know better. But at the same time, a lot of bars we design and put in a place where it's a giant parking lot and the bar's in the middle of nowhere. And we've designed it in a place that you sort of have to drive there. And that is also a design issue and an engineering issue when you think about it. But we would never consider it that way when we're, doing the work that we normally do.
Yeah, I was thinking about it in relation, like if you like always leave the milk on the counter, like on the edge of the counter, and then someone like brushes it and, not, and spills it, it's like it's not on them. Like if you're the one who never put it away, you created a situation in which that could happen. And I was thinking that in relation to like slip lanes, and that these are designed to kind of like come off of a major street quickly, and then it comes up in conflict with pedestrians.
Yeah, we put a crosswalk there and it's uncontrolled. Like there's no signal, there's no stop sign. So we all know if you're a pedestrian there, the chances of a car stopping for you are pretty slim. So if a car doesn't stop for you, like it's still their fault. But I would say we put this person in a bad situation where, a lot of these slip lanes are in places where you might see, one pedestrian like a month or something. So there's such a rare occurrence. And we've also put in a situation where maybe you have to look over your like left shoulder, for something else that's happening. And then if you hit a pedestrian, it's like, well, we're blaming them for not ceding the right of way that to that pedestrian, when in fact we've put them in a bad situation. If you put that milk carton on the edge of the table and somebody comes by and knocks it off, it's easy to blame them, but we've set them up to fail.
Yeah, very much so. And it seems like that there's like a lot of failure, potential failure built into a lot of these. And particularly when add lots of people driving and other kind of factors that it's just not going to produce any result other than failure. And we're kind of lucky when it doesn't.
Yeah, and that's I guess the feedback loop for a person that is driving or walking. Like most times you don't die, so you feel like you haven't looked for a pedestrian the last 30 times you went through this intersection. Why do you want to look for the 31st time? Because there hasn't been one, and then you don't, and then something bad happens. But yeah, I think a lot of the traffic engineering guidebooks and stuff will think about crashes as random events, like this random human errors, this random stuff. But when you actually look at the data and you look at it more systematically, the crashes are systematic. Like we know where they're happening and we can say why they're happening. And a lot of times the why is more in human error. But when you think about it from the perspective of the road user, it's not error. Like they're doing what's normal. So to me, that's something we can fix.
That does bring up the question because you do in your analogy of Driveton and here we'll talk about, measuring like where crashes happen, that like where they don't happen is also a factor, or like that's some piece of data that we should be looking at, that like why not some places and why some places.
Well, like what the easiest way to, fix a pedestrian safety problem or a cyclist safety problem is to make the road so dangerous that no pedestrian or cyclist would ever walk or bike there. And if you look at the data from a road like that, it's like, oh, look, we don't have a problem. Like no pedestrians are dying, no bicyclists are dying, but it's become such a big barrier that nobody can do those things. Like that doesn't mean it's safe. It just means that, we've excluded those people from the ability to have the freedom to get around the way they might want to. So that's one way to think about it. And in terms of drive-in Heresville thing, like we often just focus on where the crash happens. So, if I'm in downtown Denver right now, if let's say I drove here from a distant suburb and my crash happens in Denver, the blame goes to Denver. Like that's where the crash gets mapped onto our database. But when you think about like why I was even driving here, it's because I live in this far-flung suburb that forced me to do so. We don't blame the fact that I live there on the safety problem. If that little suburb isn't having a lot of crashes, it looks safe. But that design, that place, the way we built it, the way we've cordoned people off in a location where they have to drive everywhere, that leads to safety issues and they don't get accounted for the way they probably should.
Right, that they're exporting their safe traffic safety problems by virtue of being a commuter suburb.
Oh, exactly. Yeah.
Yeah, I mean we have something similar in Winnipeg where like the exurbs drive into downtown to work and then away from it. And so where do the crashes happen? Usually somewhere close to downtown.
Right. And in part, you need to understand like what led to that. I mean, why is that person there? Like where they come from, and start having a bigger, more holistic view of safety can lead to better solutions. Like one way to improve safety is to be close to where you are. Like I went to the dentist the other day, and my dentist is, like 5 minutes from me. If the dentist was 30 minutes from me, you could imagine that I have more exposure in the transportation system, that it could lead to better safety. But then if you go back to the way what we were talking about before in terms of how we measure safety, in the big scheme of things, me driving further to my dentist actually contributes more safety to the system if I don't crash. So that's when you start getting the disconnects and understanding how, placemaking and city building and regional planning all ties into this safety thing, and why it's leading us to believe that we're getting safety from what is not safe.
It certainly raises some larger picture questions. Now that the book's been out for a little bit, has there been any feedback that's like surprised you or any reaction that you've weren't anticipating?
Well, there's definitely a small vocal group of traffic engineers that don't want to hear it, that want to stick their head in the sand, and that would prefer that nobody else reads the book as well. But fortunately, they've been, like I said, a small minority. Like a lot of people are, um, reaching out to like thank me, saying that one interesting one, I've gotten a few of these type of emails, like people that were in this discipline in traffic engineering and got so frustrated that they left to go do something else entirely. And they're like thanking me for having this book that makes them feel better about the way they felt about it at the time, but like they couldn't do it anymore. And I just hope that future generations can stay here, because we need good people pushing this discipline in the right direction. So that was my advice to one of them I got the other day, is like, now stay here. Like you're in the right place. Just bide your time. It'll get better.
It's driving you crazy, so research it or, do something about it, like you tell your grad students.
Yeah. And maybe a lot of people don't have the wherewithal to want to do that. That's the direction that led me, but I can imagine getting so frustrated that you would just leave. It does make sense to me. I just went into a slightly different direction than that one.
Well, I'm going to be offering my copy to the city of Winnipeg after this, but Killed by a Traffic Engineer is out now through Island Press. Wes Marshall, thanks very much for taking some time to talk about it, and congratulations on the release of the book.
Yeah, it was great talking to you.